So let's apply what we were working on with synthetic or long division. We're given a polynomial. It's equal to 0. It has one solution equals x equals negative 1/2. Find all of the other solutions. So once we are given one of these, I can use the negative 1/2 to simplify this cubic function down to a quadratic, and then we're going to factor. So I'm going to write my coefficients: 12, 8, -1, -1. Bring down the 12. Multiply, that'd be -6, add 2, multiply, that would be -1, add -2, multiply, -2 times -1/2 is 1, add 0, that is our remainder. If we're told that something is a solution, the remainder has to be 0. So now we're left with this quadratic, 12x squared plus 2x minus 2. Or if I factor out, and that's equal to 0. If I factor out a 2 from all of that, I'm left with 6x squared plus x minus 1 equals 0. Now I'm just going to show you a shortcut that I use. So I draw an x. Some people use this for factor by grouping. And this is the first times the last, and the bottom would be the middle coefficient. So if I do, what's 6 times -1? Numbers that multiply to -6 that add to +1. And then I can easily think, okay, so that would be 3 and -2 gives me 3 plus -2 is +1. 3 times -2 is -6. I'm going to use that because I have to break down the 6x squared. So I'll be 3x and 2x as opposed to 6 and 1. Now the numbers that multiply to be 1 are 1 and 1. And I want the 3, which is 3 times 1 to be positive. And -1 times 2x would be -1. And those are all equal to 0. Now, obviously, we can either divide by 2, or just ignore the 2. We have 3x minus 1 equals 0, and 2x plus 1 equals 0. So we have x equals 1/3, add 1, divide by 3, and x equals -1/2. These are our two solutions to this cubic function. Now, moving into inequalities. This was Chapter 4, Chapter 3 of pre-calculus, if you remember. What we do with inequalities is we put them on a number line, because we are looking to answer the question not just where it's equal to 0, but where is it greater than 0 in this case, greater than or equal to. So I first factor numbers that multiply to 6 that add to 5, x plus 3, x plus 2. So my two zeros are x equals -3 and x equals -2. These we put on a number line, -3, -2, and what we're going to do is test values in between those intervals. So we have 3 intervals that we have to check. To the left of -3, we pick a number. So let's say -4, that's easy. We have -4 plus 3, which is -1, times -4 plus 2, which is -2. A negative times a negative is a positive. Now, I'm going to use a little cheat here because this is a quadratic, and the quadratic, if you think about it, does this. So I go positive, negative, positive. Now, we can check with numbers in between -3 and -2. So -2.5, we would have a positive and a negative. And then numbers to the right of -2, we could plug in 0. That's an easy number, and we get positive. In all of this, we are looking for the solution of where it's positive. So we have our inequality, it's greater than or equal to. We want where this is positive, so I'm going to write parentheses, -∞, comma, -3, bracket, union. Oops, move this over just so I have a little more space. And this is set notation, bracket, -2, comma, infinity, parentheses. Parentheses are when we can't equal, and brackets are when you can equal something. So greater than or equal to, we use brackets. When we can't be that, so greater than, less than, not equal to, we use parentheses. So that's for any polynomial. This was specifically with a quadratic. So what happens when we have a rational function? Rational, if you think about the first 5 letters of the word, are ratio. So any ratios that we're dealing with, regardless of what type of inequality, on the right side must be 0. So in this, we have to subtract. Let's just do a different color just for our sake. We have 2x plus 3 over x minus 2 minus 1 is less than or equal to 0. With a fraction, we have two locations that we have to check. We check both the numerator, where it can be 0, and the denominator, where it can't be 0. And this is an interesting question if you want to think about it as to why can you not divide by 0? If you want, you can ask Siri, and she will gladly tell you a Cookie Monster story about why you can't split something into nothing. Before we do this, let's combine these two. 1 is the same thing as x minus 2 over x minus 2. I write them so they have a common denominator. And now I have 2x minus x, which gives me x. I have 3 minus a negative 2, which is 3 plus 2, so it would be x plus 5 over x minus 2. It's less than or equal to 0. So again, I have to check two spots. In my numerator, what makes this number 0? And then in my denominator, what makes that 0? Because my domain in this problem is x is not equal to 2. But my x-intercept is where the numerator is equal to 0, which would be negative 5 comma 0. So these are the two values that I would put on my number line. So I have negative 5, and then I have positive 2. Now I'm going to check a number to the left of negative 5. Let's say negative 6. If I had negative 6 plus 5, that's a negative number. Negative 6 minus 2, that's a negative number. A negative divided by a negative, so I have negative over negative, is a positive. I check a number between these two, so let's try 0. I would have 5 over negative 2, or positive divided by a negative, which is negative. And then I have a number to the right of 2, so let's say 3. I'd have a positive divided by a positive. So I have a positive term there. Again, we are checking the inequality where this is less than or equal to 0. So where is this negative? Where are the numbers lower than 0? So I have from negative 5 to positive 2. But I know I can be 5, and I can't be 2. So if I use my set notation, I can be negative 5, bracket, and I can't be positive 2, parentheses. This is a far easier way of denoting the interval, but if you wanted to use inequalities in a much less precise way, you'd say x is greater than or equal to negative 5 and less than 2. Either of these options work just as well. Let's keep going with our rational functions, so our fractional functions. We're going to talk about simplifying rational expressions, and then we'll call it for this video. So we have two methods. The first one is to factor and reduce. I don't like using the word cancel, which a lot of people use. Cancel means like you're getting rid of something, and that's not what's actually happening. We are just simplifying this more. The second thing that you might have to do when you're simplifying a rational expression is multiply the entire expression by the least common multiple of the denominators. Denominators. So let's see what this means. The first one will be factoring, simplifying. The second one you can see is fractions over fractions, and we'll have to do multiplying by the least common multiple. So gladly, if you want, pause the video, try these problems out, and then watch to see if you did it right. If not, let's say orange. Let's see how well this right. GCF on the top is x. I'm left with x squared minus 9, which also would then factor to x, parentheses, difference of squares, x plus 3, x minus 3. And then the denominator is numbers that multiply to 12 that add to -7. So that would be x minus 3 and x minus 4. -3, -4, make -7. Negative times a negative is a positive. So now I'm left with x minus 3 and x minus 4 in the denominator. Now, this is where we reduce. And when I don't say cancel because we're not getting rid of something, we're simply saying that x minus 3 divided by x minus 3 is equal to 1, because any number divided by itself is 1, leaving us with our final expression of x parentheses x plus 3 all over x minus 4. So you can see how all of this starts building. And now our book, and if you want to, I prefer this answer. It's fully simplified, but you could easily redistribute the x on the top and be left with x squared plus 3x over x minus 4. Either of these answers work. I personally prefer the more simplified way, but sometimes it will ask you, and to make your life a little more easier, if you redistribute any of those outside terms. Okay, last problem for this set of videos, and then we'll go into rationalizing the denominator in the next video. How can we make this fraction easier? I got fractions on top of fractions. So I want to look for what is the lowest common multiple between the numerator and the denominator. So if I look on the top, the common denominator would be 5x. If I look on the bottom, the common denominator would be 25x squared. So the lowest common multiple between all of these things would be 25x squared. So I'm going to multiply, aka clear the fraction, by 25x squared on the top and 25x squared on the bottom. Now I won't have to deal with any fraction, and I can simply simplify. So 25x squared divided by x would be 25x. 25x squared minus, or divided by 5 minus 5x squared. Over, similar on the bottom, I'd be left with 25 minus x squared. Now, I know this looks a little different than what you're used to. On the top, GCF is 5x. So I'm left with 5x minus x. Yep. And then the bottom is still the difference of squares. It's just a different order. So instead of x minus 5, x plus 5, we're going to write 5 minus x, 5 plus x. Let's write the numerator correctly. 5 minus x. 5 minus x divided by 5 minus x is 1. So we are left with 5x over 5 plus x. So take a look at this last question. Give me a little feedback on the pace at which these videos go. If it's too fast, please let me know. But I look forward to working through some of these problems with you guys in class.